Hello, everyone. This is Oliver White coming to you live from beautiful Prague, Czech Republic. Our guest today is Kevin Weber, who is the enterprise advocate at Typesafe and author of some very popular articles on Medium, such as A Journey into Reactive Streams and Transitioning to Scala. While I introduce the webinar today, I'm going to launch a quick poll asking you about your system architecture. So today we pose a question that's probably burning in your mind, which is, what the heck are you going to do when your aging architecture finally begins negatively affecting your business? Do you start over from scratch? Do you hire a new team? Do you look into consulting? What if none of these options are possible? So today, Kevin will review his experience re-architecting Walmart Canada's online business after 2 years in a row of system failures during the worst possible time for e-commerce giants, Black Friday. As always, if you have any questions, please put them into the Questions tab in the GoToWebinar control panel. My final note is to invite you to check out what's new in Reactive Platform. If you don't know about Reactive Platform, or RP, it's our certified, tested enterprise platform that includes application monitoring, deployment orchestration, self-healing features, and other commercial things not found in the community projects. So you can check that out on typesafe.com or email me personally at oliver@typesafe.com. So that's all from me. Let's hand it over to Kevin.
Thanks, Oliver, and thanks everyone for joining. So I am Oliver's from beautiful Prague. I am from less beautiful but still pretty amazing Toronto, Canada. And this is a bit of a two-part story. It's a story of revitalizing aging architectures with microservices framed around personal experience of replatforming fairly major e-commerce retailer, Walmart Canada. So without further ado, I'll get started and talk a little bit, just to level set a little bit about the Typesafe Reactive Platform for those that are joining who are not familiar with it. The Typesafe Reactive Platform is really composed of three key parts. The first being Play, which is a RESTful API framework. So this is very important in the context of microservices, is that there is a bit of a misconception that Play is pretty much the direct equivalent of something like like Rails, where we're primarily used to implement user interfaces over the web. But actually, it is essentially a RESTful API framework. So it's in this kind of architecture that we'll be talking about. Think about Play as kind of the API gateway to a larger system. And that larger system would be composed of akka, which is our distributed computing toolkit. And akka is really the key piece of an architecture, at least microservices architecture in this context, because of the things that it offers and the things that we'll get into. For instance, an asynchronous boundary, things like location transparency, being able to take work off of the machine that processes a request from another service and being able to move it on to essentially commodity hardware and spread that around without having to be concerned about physical limitations and things like shared mutable state and staying on the same machine or even the same VM. Now Spark is very interesting, where Play and akka are a core part of the Typesafe Reactive Platform. Spark is not owned by Typesafe. It's Apache product, but it is written in Scala, and so we offer commercial Spark support and helping teams to make the most of Spark, especially in context of teams that are productionizing things like machine learning and so forth. So we'll talk about Spark towards the tail end and how that may fit into a modern microservices architecture. And then we also offer tools that are more infrastructure related. For instance, Conductor is a way to manage clusters of computers, and monitoring is a way to monitor all of your entire system in production.
So, hey, Kevin, Kevin, sorry to
Yes.
interrupt. I think your mic is kind of going on your collar or something because your voice is kind of fading in and out at times. Just wanted to
Okay,
mention that.
is that a little better?
Yeah, that sounds perfect right now. Cheers.
Okay, great. Thanks for letting me know. One of the key questions is why replatform? Why are people looking at replatforming? Really, it's an industry-wide sort of phenomenon. Is the technology is advancing so fast, and architectures are, frankly speaking, especially in the enterprise, really not keeping up with the expectations of the market. And I'm not just talking about end users. I'm talking about lines of business. So, for instance, a line of business comes to your team and asks for a new feature. Really, they're looking to keep up with the demands of the market, and so building these types of microservices architectures are really key for staying in front of the demands of the market. It's not just a sort of replatforming for the sake of technology or just purely about non-functional runtime requirements. It's about the overall market in general and sort of what users expect and what lines of business expect to stay competitive. And so if you look at enterprise systems, a lot of enterprise systems that exist today, kind of designed in this sort of 2005 architecture, I call it, which is really designed around desktops and laptops and physical, is sort of big boxes, right? And these boxes hitting potentially an app server somewhere, and perhaps that app server is replicated, perhaps it's not, but essentially it's all of the traffic for your entire business going to one box, and then maybe there's some kind of session replication. In case that box fails, maybe you can fail over to another box. But this is really kind of a common architecture. So it's kind of a big bang. It's all of your eggs in one basket, not just operationally, but development teams kind of working on these monoliths, and I'll talk a little more about that later. And this is kind of what we're moving towards today, which is not just desktops and laptops, but mobile devices, Internet of Things. So in order to keep up with that demand, especially Internet of Things, especially mobile, has put such a strain on sort of what I look at as a modern architecture. What people see, sort of like the API or even what a line of business may see, it's kind of like the tip of an iceberg, right? And just this iceberg under the waterline, it's not seen, but it's expanding. It's expanding, and this is really where we're leading towards. Is not just what we consider the Internet of Things today. It's when we're connecting our cars to back end architecture. For instance, BMW's latest voice interaction software. It's not just processing your voice in car. It's actually emitting requests off to a server for processing and actually sending those results back to the car. So you can just imagine when we start connecting all of these devices together, the kind of strain that's going to put on some aging architectures if they're not replatformed. And this is just accelerating at a rapid pace. So for instance, for those of us like me, just for context, as I started out as a Java developer. I've been a Java developer since the late 90s. So when I cut my teeth in sort of lead and architecture roles, that would have been around the sort of 2005 mark. Basically being a developer from the late 90s to about the mid zeros, and so the systems that I were designing were really built in this era where today Facebook is actually bigger than the entire internet was when I was first designing systems for the internet. And really, I still see that same architectural style today when I talk to people, and it's almost this modern but pre-internet architecture, and this is really the world that we should be keeping in mind when we're architecting systems and replatforming, is thinking about 4 billion connected people, 25 million apps, 25 billion embedded systems, and 5,200 gigs of data for every person on Earth. So it's not just a case of a microservices, that term isolated by itself. It's even thinking about if we get to a point where we have 5,200 gigs of data for every person on Earth. are we really going to gain insight by storing all of the things? Like, let's log all of the events that our machines are observing, put them in some kind of data lake, and then process them overnight, hope to gain insight. It's really not where systems are moving towards. So when we have this much data being generated for everybody on Earth, we're going to need to think about not only how do we sort of re-architect for what we consider our core systems, but how do we move away from ETL, move away from any kind of processing of data that's resting, and move towards completely real-time systems. And I think microservices architectures are just sort of the beginning of that, moving towards not just real-time systems, but completely real-time organizations. So this is to kind of circle back to my own experience. I felt this. A lot of the things that I've talked about personally felt this. So this chart pretty much sums up why that when I was in a lead and architecture role with an agency that rebuilt Walmart Canada, why we look towards the Typesafe platform and reactive techniques and principles specifically is year over year. What you're looking at is year over year peak traffic on Black Friday for Walmart Canada. So you can see 2010 peak traffic. It's about that sort of like million page views per minute into 2011, 2 million, and then boom, we're seeing a seismic market shift where people are just more apt to be spending money online rather than driving to a physical brick and mortar store. So year over year from 2011 to 2012, that system, that one system went from 2 million page views per minute to 6 million, and that's exponentially increasing even today. So really what we're talking about here today is getting in front of that. You don't want to be so this is what catching up looks like. This is as the team that I was leading was beginning to build Walmart Canada's new platform in 2012, is live tweeting on Black Friday when the old legacy system was down most of the day, and it was down because it was that 2005 architecture that I mentioned. It just could not handle the sort of like even the 1 to 2 million page views per minute. So moving from 2 million to 6 million, it just started to essentially make it impossible to keep any kind of user experience, positive user experience. So really what the goal of the team was getting as close to 100% availability within reasonable cost as possible. So getting towards that 9 nines. And I'll spoil the surprise that after the after the new platform was launched, zero downtime on any future Black Friday. So this is, achieved that through some of the techniques that I'm going to talk about today. And not just availability and not just responsiveness, but consistency. It's not important to just keep your system up. It's important that if, for instance, minute over minute you experience a spike of traffic on your system, can your system be elastic enough to scale out to sort of handle that peak without negatively impacting experience. So if your system stays resilient, it stays online, but response times double because there's a spike of traffic, that's really going to upset people, and they'll view that inconsistency as a lack of quality and a lack of, I would even say, a lack of reputational trustworthiness. So it's just important to be predictable. And not only availability and responsiveness, we talk about these as runtime concerns, but also being completely responsive to architecting for the business, anticipating that architectures are evolution. They're not, sort of these big bang singularities, but they're constantly evolving. So when we build monoliths, it really makes it difficult for a system to evolve beyond a certain point, where it's kind of this point where you get to the fact that modifying the system, like let's say you want to add some kind of form to, I don't know, capture emails or something like this. You get to this point where it's like you look at what is the effort to do this simple thing that if I were to completely rebuild the system, this is a day of work. And then your monoliths get to this point where it's like, really, that's a month, that's 2 months of work. This makes no sense. And we just want to avoid that. There's the techniques are mature enough that we never need to get into that situation again. So this is what the sort of first step of the revitalized Walmart architecture looked like. It's not what I would call a microservices architecture. It's what I would call a mini services architecture. So it's kind of it's moving towards something that we could call microservices, but slowly. It's more like what that team did was essentially chop up ATG as much as possible to add APIs on top of things like Indeka, and start to integrate with the wider world in that e-commerce context. If you're to go to Walmart.ca right now, there's actually no static pages, for instance. Everything is dynamic. So somebody from the line of business can actually in real time, say, create a dynamic page with a dynamic URI that integrates into the wider site, and do that all behind the scenes and launch it without code changes. So, it's not a question of just building these systems in isolation. There's kind of the real world of integrating, and that's where there's techniques and microservices and patterns like circuit breakers, for instance, to maintain resilience, and Saga pattern to handle long-running transactions across location boundaries in a distributed system, that we can start to embrace to kind of move towards this model. So this project had a real business uplift. Conversions were up 20%. This is like literally overnight. Mobile orders up 98%, because even more important than the user experience on desktop was perceived latency and perceived sluggishness on mobile is even more damaging to conversion. So once that consistent experience was delivered to mobile users of Walmart Canada, the orders shot up. So it had a real business impact. And the thing that I think that I can speak for the team that we were most proud of is really the lack of downtime. So going from the tweet that you saw earlier to no downtime on the Black Friday or Boxing Day is like one of the bigger shopping events in Canada. I don't think that really translates to America, but it's kind of like a Black Friday or Cyber Monday. And so Walmart Canada experiencing no downtime on Black Friday or Boxing Day was huge. So there's also an operational side to this, moving off of expensive hardware onto commodity hardware and saving really like about 40% compute cycles. So making the most efficient use of the resources that are available. It's a great, not just a scaling out story, but scaling up. So where to begin? Where do you start? Well, really when I talked about expectations in the market, there's pressure being placed. There's the real-time, always connected, critical and consistent expectations being applied. This pressure being applied to these old-school heritage architectures. Where we have a single server with a single core and snapshots of data. And moving now, we need to move that from a server to clusters, from a core to cores, from local handling of state to distributed handling of state, and from snapshots of data to streams of data. So really, it's a story of taking a step back and thinking about the engineering behind it. So it's not just what I consider is it's just sort of like flying into microservices. We need to have some principles behind that. So microservices is kind of the how, but there's the why and the what. And so really this is what we're moving towards, which is simple, right? Well, that's too complicated. Asynchronous, non-blocking, real time, all of these terms, it doesn't give us a vocabulary to work with across teams and to be able to talk to business stakeholders. So myself personally, I embrace this idea of reactive as sort of not just a vocabulary, but a maturity model for modern distributed systems, the kind of system that I wanted to build, where the ultimate goal is building a responsive system, and in order to get there, we need these traits. So the goal at the top the traits in the middle, and the traits would be elasticity, being able to scale out on demand, scale back in during less demand. So a peak traffic, being able to dynamically, without manual intervention, add nodes to a cluster, replicate services across that cluster. And then the resilience of, if a server goes down, can I spawn everything up that was on that server automatically to surviving nodes of a cluster, for instance. And so those are the traits. There's no way to get there without, we fundamentally believe a message-driven architecture is the best way to approach us, because we need things like location transparency. If there's no way to deliver systems like this without being able to move work off of one server to another server. So a server crashes, no big deal. One of the stories I like is Google, for instance. Actually, one of their data centers, Sam Newman was talking about this in one of his books, that he visited Google and he noticed that in their data center, they had stopped actually screwing hard drives into a rack or anything. They're actually just Velcroing hard drives onto the wall. Or into these racks, and so they could literally, like, when a hard drive fried, they could literally just like unvelcro it, throw it in the trash, and Velcro a new one in. And so we're essentially getting to that. It's like getting to the point where if a server fries or hard drive fries or whatever, it's no big deal. We just kind of like throw it away and ask for a new one. And all of our state, all of our in-flight transactions, everything doesn't really skip a beat. It just moves on to something that's still available. So really think of reactive principles as kind of like the principles. It's the why, and think about the sort of why and what. Microservices to be more of the strategy, the architecture. So we get into terms like that I'll share, bounded context. So if you really want to kind of like dive headfirst into microservices, I highly recommend reading Domain-Driven Design by Eric Evans. And there's another book that I highly recommend called Implementing Domain-Driven Design. This is a high-level talk, but to get more into the weeds of code, you can those two books together are a great pair, and just can't recommend them enough. And then we're moving towards not just things like what you may have heard of with domain-driven design, but moving even away from traditional relational databases and moving more towards immutable data, so event sourcing. So being able to issue commands, create journaled entries, and being able to sort of emit events from that happening, rather than sort of destructively mutating data in relational databases, just never to delete, create new data. So if you need to change something, to create a new record rather than delete anything. And that helps us get towards eventual consistency, because this is important, is if you kind of embrace microservices but still connect everything up to a relational database, it's not really a distributed architecture. It's not gonna scale. And then the tools, what we offer, the Typesafe reactive platform, Play, Akka, and Spark. And so these are the heritage systems, like I mentioned, integrating with sort of these databases, cache, everything sharing. So now if you've got a team, like let's say you've got a search team, a browse team, and a team handling orders, recommendations, now you've got this sort of one system that's constantly being where development teams are kind of stepping on each other, and they all move in tandem. So it's even from release management and sort of expanding the system, very difficult. Whereas we want to move to these future systems where you can have something like a product team, you can have something like a search team. You have these bounded contexts where your organization is actually refactored, in a sense, into smaller, independently moving pieces that, for instance, product service, there could be much more ROI to maybe make a major update to the product catalog. And you don't want to impact the rest of your system. And so really where microservices, and I mentioned domain-driven design and bounded context, is where you're not creating these canonical data models and these kind of like all just big monolithic systems. Each bounded context can have its own vocabulary, but more importantly, have its own data. This is one of the critical changes that people ask about in terms of a microservices architecture is now, if I just sort of added these bounded contexts kind of speaking to one relational database, all you've done is kind of move some of the challenges that may be on your monolithic systems, and you've just kind of like moved those to a schema level, right? Where again, it may not be like a big bang all or nothing thing, but even thinking in terms of can you start to kind of like tease apart the namespaces in your schema to kind of create these bounded contexts, maybe even at a namespace level, before you physically start to carve your database up, and maybe even at an architectural level, at a code level, start to think about teasing things apart at a package level and using a tool like maybe even like Restructure, a tool that can look at cyclic package dependencies and see if, once you've got to a point where there's no cycles within your packages, starting to then like break these systems apart, at a schema, start to break those out into different databases, or different for instance, maybe one's write heavy, so you no longer even need a relational database. Maybe you move towards more of a journal, and then at a system level, or a code level, start to refactor into services. But these are the systems that we're looking to build, because now I can take replicas of services. I can scale them independently. I can release them independently, because we're moving towards these clustered microservices. So this is a very trivial 3-node cluster, but now imagine thousands of nodes, and being able to dynamically scale and replicate services across these nodes. And for instance, in this simple diagram, if .240 crashes, move those services and even move the state that's associated with those. Maybe it's akka, and you've implemented a finite state machine in akka, being able to move that onto a surviving node in real time. And that requires embracing new concepts and patterns. So we're essentially embracing distributed computing, distribution of, how do you persist data? It's a different scenario. New patterns like circuit breakers, new patterns like the Saga pattern, in order to make sense of transactions across outside of thread local, when you lose the sort of like locality conveniences that we've all relied on to kind of like simulate ACID, right? There's really, I mean, we're all bound by physics, so there's really no such thing as absolute consistency, but we've done a really good job of simulating that at a sort of memory space level. But once we move towards distributed computing, we lose that. So we have to think about different ways to embrace eventual consistency. So maybe you have ACID within a microservice, but outside of that bounded context, then you embrace eventual consistency. And this is important. This is when I tie this back into Walmart, one of the things that reactive and play and akka led us to is moving away from sort of like the thread per request model, and this is what thread per request really looks like. Is a request comes into our server, and that inevitably that request requires a trip to the database. So we kind of cross this async boundary at a sort of transactional level, database transactional level. Now the database starts working, but we actually block the thread, and we block our server from making that thread making progress on any other operations that are being queued up. So then we wait, and then eventually return a result, and then we can start working again. But when you start moving, this may seem like trivial, but when you think about the limitations, like how many threads per VM can you have? What's the upper bound of that based on heap size and things? It starts to become really critical when you're thinking of these old 2005 architectures bounded by thread pool size, and then start to move from 1 million page views per minute to 2 to 6 to 12. So we really need to have a complete and total async boundary where we can process a request and then return immediately, return that thread back to the pool, have it work on other operations, and let the database work offline, and then have the database when it has something for us, maybe it doesn't return a result. It emits something back to our system, and then we can process it. But we're not counting on it. We have to start thinking about, what happens if there's a network partition or we can't communicate with our database? How do we deal with this at an architectural system level? Like, what can we? It's back to consistent responsiveness. It's a lot of architectures that I've seen, they almost treat databases and things like this as natural resources. Like, the ocean will always be available. But when you start thinking in terms of distributed systems, it's assuming nothing is available. Anything that goes outside of that specific bounded context may or may not exist. It may or may not return any meaningful information to us. So how can we sort of architect our systems to, like maybe if the database doesn't return a response, we sort of default to something sensible, or come up with, I'm going to give the database, like 1 second, and then I'm going to return some kind of default, or maybe not even render part of a page or something like this. And so, when you think about things like, when we're moving towards microservices architectures, if we were to think synchronously and to think thread per request, that quickly just gets out of hand. We start queuing up requests and then issuing, like in this sort of like trivial example, we have 10 synchronous requests that each take 100 milliseconds. Then our overall response takes 1 second, which is a waste of resources. When we can move, when we embrace location transparency and distribution of work, we can embrace full parallelism. And if we have 10 requests, we can actually offload those to 10 different threads, make progress at the same time, or even maybe these are compute intensive, so we might need to move this work to 10 different VMs or 10 different machines, and then sort of like fan back in and return a meaningful response. And so that's like the performance side, and then move towards these systems where one service can be sort of like speaking messages and kind of be emitting requests out to not even caring. Like, so in this diagram we have a red service on server 1 that's communicating with references to 3 other services. But the reference in this case I'm drawing, these are akka actors, but having stable references. So in the event of say the service doesn't really even need to care, this is part of location transparency, is the service itself doesn't even need to care what physical server that the recipient of the message is living on. It simply communicates with a stable local reference and doesn't even expect an immediate response back, because it's telling things and then being able to handle events that come back in. Because when things like this happen, so for instance, kind of back to that Google failing hard drive, velcroing out the bad hard drive thing, server 3 blows up and dies. The service is running on server 1 in an ideal architecture. That service can just be firing messages to service C. It doesn't care that server 3 crashed and that service has got spawned up on server 4. It's just firing messages and being able to handle the inevitable event that may or may not come back. So that's really the kind of system that we want to get to. In a microservices context, really where to start is we need a few pieces in place. So we need on the development side, we need obviously to choose a language. We need to have some sort of API in place, and then there's things behind the scenes. So in the Typesafe reactive platform, we have akka streams that can do per event processing of requests and handle that as graphs. So be able to handle the sub-second latency processing in a very easy way using a very easy to understand API. And then we have actors, which are very, very flexible, and you can really build any kind of system you can dream of with akka actors. And then even take it to the next step where start to explore things like akka cluster and akka persistence, where akka cluster takes it to the next step where your actor system can actually sort of span multiple nodes, form this completely distributed architecture, but not even akka completely abstracting location away from that cluster. So members can join, members can leave, and actors can just kind of spread across many machines, and you don't have to like physically know where the actors are living. That's all handled for you. And then on the infrastructure side, we need to be able to monitor our systems. We need to be able to manage our clusters. So I showed you earlier, a simple 3-node cluster. Not having a cluster manager in place, let's say you move towards a 10 or a 20 or 30-node cluster, expecting your ops team to be able to now if I'm a developer and I get a pager support request overnight, and I need to know exactly, okay, this service is failing, go to the ops team and say, hey, like what server is that service deployed to, for instance, without some way to manage the cluster. That's kind of a nightmare. So you can kind of like manually manage a cluster, maybe if it's got 3 nodes or 5 nodes, but you get to a certain point where something like Conductor, a cluster manager, is just vital, because we've moved away. None of this, one thing I haven't talked about are app servers. So none of our technologies play akka. We don't deploy these to app servers. They're really standalone things that we bring up on a VM or in Docker, and Conductor can manage that for us. The sort of life cycle of starting and stopping, and if a server fails, being able to move it to a different server, and then we need a way to monitor the health of the system in real time. So that's where our monitoring tool comes into play. No pun intended there, and have sort of like distributed logging. So being able to log, machine type events at a cluster level, rather than ask our friendly ops person to go to each individual server and pull logs. That's like, if you're doing that, I mean that's just such a waste of effort for ops teams, and move towards thinking of our system as a cohesive whole, no matter how it's physically distributed. And then we need things like service registry, service discovery, and security, and that's what really where we are at Typesafe is being able to provide the tools to achieve all of this. And so I'm going to cover a little bit for those, there may be people on spending about another 10 minutes and cover play akka and Spark, and then we can take some questions. Just for those people on the call that may be using akka and they're not familiar with play, or vice versa. So really, play is a stateless MVC framework, very familiar if you're used to Spring MVC or Rails, with some very significant differences. So it's really not about, play is not about state. Akka is all about state, play is not all about state. It's about rapidly being able to process requests. It's about implementing an API and being able to do things like routing and so forth. So pushing state either to akka or up to the browser. That's really where play fits into a microservices architecture, and being able to implement the API gateway with play. So having play handle things like security, having play handle authentication, authorization, things of this nature. That's really its wheelhouse. Very familiar MVC paradigm. It embraces flows of data. So if, for instance, the really cool feature of Play 2.3 is if you're, say, for instance, implementing WebSockets, you can actually do the WebSocket handshake with play, and then all of the bidirectional WebSocket communication can be offloaded to a specific akka actor, which makes it very, very easy, because then it's fully evented. Essentially, it's kind of evented at a JavaScript level or whatever you use on the front end, and evented behind the scenes with akka. Supports SSE, has experimental reactive stream support in Play 2.4, and I still believe we're targeting full reactive stream support for any kind of streaming with Play in 3.0. File uploads, things like this, and really great integration with akka, so you can distribute work off of the machine that's handling the initial request. And so akka is really, this is the guts of, you can think of maybe Play as what sort of exposes your services, and actors is how you actually implement your microservices. So you can think of in terms of like akka fits very well with domain-driven design. So you can start to think of that when you're trying to figure out how do I architect an akka-based system, is thinking domain-driven design when you're doing it, because akka provides you with all the tools that you need. It provides distribution, location transparency. So these actors, in this case, they could live on the same VM. They could live on different VMs on the same machine. They could live in different data centers. It doesn't really matter. You're abstracting that because you have that distribution with message passing. It's not something that, as a developer, as an architect, you have to care about directly, and especially when you're coding. But then you can maintain state. So, for instance, akka has all sorts of features to help maintain state. So, for instance, modeling transactions as a finite state machine. So, you maybe somebody's going through a flow, a 4-page like order flow or something. You can model state transitions and current state with an actor, and sort of move that off of Play and move that off of the ways that you may have done that before. And then the great thing is using you can get as deep as you want to go and use persistence. So have a persistent mailbox. So if for whatever reason the VM or the server that the actor lives on crashes, you're not starting from scratch. You can spin that up on another living node and play back you snapshot the mailbox, ongoing, play back the mailbox to get back to the state and continue as if nothing happened. So there's so many options at an architectural level. And think about that. If you have any architectural questions, I'd be happy to answer them on the webinar or even offline. So that's one aspect of it. Having isolation is really key, because we talk about scalability and things like this, but really the key of everything is, without resilience you have nothing. I mean, you can have the most scalable, gorgeous system that you can architect, and if it's down, it's not making any money. It's useless. So the core of akka is providing this concept of supervision. Is that things like what I talked about, where it's like, if this database isn't available, if the system isn't available, really not thinking in terms of, hey, I'm gonna write my blue skies, everything is great code, and then maybe you wrap it in a try catch. It's thinking in terms of, we're building distributed systems, everything potentially could fail, and how do we deal with that at just really at a nuts and bolts core level. And that's where supervision comes in, where every actor within akka has a supervisor. So and every actor is addressable. So in this case, for instance, Foo has 2 children, A and C, and A has 3 children, B, D, and E. So really what it is that A is a supervisor of B, D, and E, and Foo is a supervisor of A. So for instance, let's say B crashes. The system that, let's say we've embraced akka clustering, B is on a different system or on a different physical machine than A. A can still supervise it, so it can know oh, okay, my child has died. Um, what do I do? Do I try to restart that child actor? Do I kill myself? Maybe I want my supervisor to handle this. All sorts of options, but being able to bake that into your code and at an isolation level, at a physical level, is just way beyond anything that we can do traditionally. Like for instance, the best that you can do with your try catch is handle exceptions, assuming your VM is still available, assuming the machine hasn't like exploded into a ball of flames. But once you lose that, I mean, you're down. So this opens up an entirely different avenue of resilience than architects, a totally different toolkit than architects had, even 5 years ago, or however, long ago from the last time you've replatformed. And getting into these like dedicated separate air channels, because really like the goal of supervision is to be able to take, like for instance, let's say I'm modeling a coffee maker, an office coffee maker with akka. So let's say there's still some office coffee makers, like I'm on the road once in a while, and there's still some that require money. So I put some change in an office coffee machine, and then it spits an error it's kind of like I'm out of water. Thinking to the movie Office Space, this is kind of like PC load letter. I mean, this is this sort of frustrating. Having a single air channel is really the one of the most frustrating things as a user. Just having that service just spit back this error that as a user I can't do anything with. The only thing I can do is take my business somewhere else or be really upset. But with akka, what we're moving towards is having dedicated separate air channels. So the supervisor being able to reason about, okay, I've requested that I want to buy a coffee. The service is essentially, think of this as the child is emitting this, I'm out of water. The supervisor can essentially just fill that machine up with water, and then the client gets its coffee. So we're getting into this. This is what a dedicated separate air channel looks like. Having the only thing that a service emits back to the client is validation errors. Having the system as a cohesive whole with supervision be able to deal with all application errors. And really think about, there are very, very few system level errors that I ever want to admit back to client. If you have a fully distributed resilient system, literally the internet has to blow up for you to admit back to a client that I can't do this thing that you want me to do. Even if a third party, you could be saying to yourself oh, what if all my third party systems are down? That's still dedicated separate air channel. That's not a validation error. You should be returning something meaningful with consistent responsiveness. It's that consistency. So yes, all of my third party systems are down. But what's my consistent responsiveness in that scenario? And using supervision to model that, and being able to achieve that with things like clustering, being able to look at creating this sort of cluster of actors that kind of transcend IPs and machines, and just being able to address them like I showed you with the traditional akka namespace, no matter what machine they live on. So those are the systems, and that's what we're moving towards. So that's kind of the microservices part of it. And then there's the second part that I want to talk about, which is Spark, which is once we move towards microservices, moving towards these fully event-driven systems, and also treating data as events, getting into things like productionizing machine learning and per event and mini batch of stream processing, and even moving our ETL systems away from something that we do overnight. We spend 6 hours from midnight to 6 a.m. performing maintenance on our data or something like that, or rebuilding a product catalog or whatever, and having that always real time. And now it's possible with technologies like Spark to get there, is leveraging pieces of akka and pieces of Spark to build, using akka to process individual events, and then using Spark, sort of sub-second latencies, and then using Spark in that kind of 1 to 10 second latency mode. But thinking about it more in terms of like, latencies of like 6 hours right now. If you're doing ETL work overnight, it really, all the tools are now in place where you can take those like 6 hour latencies and turn them into 1 to 2 second or 10-second latencies by leveraging something like Spark. And just treating all data as streams, as a series of elements that are emitted over time, and that can be events or even chunks of files, but they have no beginning and no end. So you're just like essentially attaching some kind of process to a waterfall, like a stream, and doing sort of like observing that and potentially operating on the stream and potentially just detaching from it and ignoring it. So it's a major architectural change, kind of beyond the scope of just talking microservices. But it's something to think about when you're thinking microservices. It's all part of the ultimate goal of responsiveness, and leveraging akka streams in per event processing and having back pressure. And again, back pressure is a little bit of a more in-depth topic, but looking up into terms of some of the real challenges of stream processing were things like, if all of a sudden I had a producer that was emitting way too many events, just out of nowhere a producer just completely like started spamming my consumer in a stream, you could easily overwhelm a consumer and crash the machine, crash a VM. And that's really what held us back from building stream processing systems. When you're thinking about the resilience, just very hard to get right, to keep that stream always available. But now akka streams and reactive streams embraces back pressure. So being able to have these dynamic push-pull streams that can kind of signal back to a producer, kind of like, whoa, you're overwhelming me. You need to like either maybe start persisting some of these events, or window the events. Maybe instead of sending me an event every millisecond, start to conflate the events and send me one every second. And doing this all in real time without manual intervention. So that's kind of like a 100,000 foot, somewhere between 110,000 foot overview of not just Walmart, but where I would envision a system like that moving towards. Further is that sort of like mini services to microservices to completely real-time system. And this is a little more about, I mentioned Conductor, our cluster manager. To basically manage your reactive platform across a cluster, and Typesafe monitoring. So know exactly what's happening within your system, be able to monitor your actors and get real-time insight into things like mailbox size and average processing time of an actor, and really be able to use that to sort of like build improvements into the system, or kind of like get to root cause analysis very fast, or mitigate issues. There are more commercial features, so Play, akka, these are open source technologies. We offer commercial features on top of that. Typesafe Reactive Platform is the commercial platform, and then that gives you access to things like akka split brain resolver. So have your systems fully resilient, even if there's a network partition. So if there's a network partition in the middle of a cluster, have the cluster be able to self-heal, and that's a very difficult thing to get right. So we've built that for you. Cluster support for Docker, user quotas. So if you want to implement some rate limiting into your APIs, you can do that. And if you're in kind of like a heritage or legacy SOA type environment, we have completely, as I mentioned, async and non-blocking before. We have a commercial async non-blocking SOAP driver for Play. And then everything's kind of framed around project success subscription. And I was a customer before joining Typesafe. I got a huge amount of value out of this. Being able to ask the Typesafe engineers questions. If you're building out a Play app, not getting stuck, not living on Stack Overflow, but being able to ask us, sort of best practices questions, or get your team unstuck. So a ton of value, and we'd obviously be happy to talk more about this. So that's what I have. I'd be happy to take questions either now. You can add me to Twitter if you'd like to chat there, or you can send me an email. But really, if you'd like to get started, I would recommend just following this link. So thanks a
All
lot.
right. Thank you, Kevin. That was an excellent presentation, and I like some of the new drawings that I saw for the first time today. So take a
Yeah,
drink of water. We definitely
coffee.
have a lot of questions. We have about 5 minutes to get through as many as possible. But folks, if you do have questions, please feel free to email me at oliver@typesafe.com, and we can get those answered for you.
Yeah, and don't hesitate. 5 minutes probably won't be enough to get through them all. But
Yeah.
I'll be around all afternoon, so you can ping me if you're on Twitter. Just
The
add me and
first
send me a
thing
direct message or an email.
So the first thing, would you mind writing into the chat, or maybe I can do it? Can you remind us of those two book titles that you mentioned midway through the presentation?
Oh, I'll keep it up here, but the book titles is Domain-Driven Design uh,
Domain-driven design, and the author?
by Eric Evans, ERIC, Eric Evans. I'm
Okay,
literally it's on my like right next to my lap right now. So
okay, that's
it's
great.
it's kind of like my Bible.
Can you
And,
make a
and an
selfie with it?
architectural element. Yeah, maybe I can. No, I'm not that clever.
Okay, so we've got DDD by Eric Evans
Yeah, and then implementing domain-driven design by Von Vernon. I might have butchered
by
his
who?
name,
What?
so don't hold it against me. Von Vernon.
Von Vernon?
Don't ask me how to spell it. Maybe Vince Vaughn wrote it. That's as close as I'm going to get to the name off the top of my head. But it's I feel terrible because it's
All
on my
right.
shelf.
Great.
And
So, folks,
yeah, look those up.
I popped those into the GoToWebinar chat, so you can copy those. Uh, there were a couple questions regarding the difference between microservices and SOA, service-oriented architecture. And I know that we're
Yeah.
actually publishing a white paper on this in just a few weeks. Do you have a short answer?
Yes. SOA was really about it wasn't about resilience. It was about governance. It was still, how do I have this canonical data model, and how do I somehow enable my entire organization to work using this canonical model of the world, and then integrating with these things like ESBs, and then governance, and I mean, I went through a few major SOA implementations. They were I don't want to say disasters, but they were challenged, and it's still back to the too many stakeholders, too many hands in the cookie jar. Microservices is not like that at all. I mean, we're not talking ESBs. We're not talking, any kind of like, once you get to a point where it's like we have a microservices architecture, then there is some centralized team somewhere. Unless you're talking about your operations team that's managing your cluster, it's probably not microservices, because the goal is, it's not canonical data models. It's multiple canonical data models. It's having independent, fast-moving teams be able to take ownership of a conceptual slice of the architecture, and run with it. And that's really what domain-driven design talks about, is how do you even design a system with multiple canonical models. And once you're able to do that, then you can just make that happen physically. And then the net result is that you have essentially, your organization moves into something more like how LinkedIn works, where you're not thinking of it as this like one enterprise system. You're thinking about all of these small companies within your larger company, and they all need things from each other. They all consume APIs from each other, and that's really the ultimate goal. And then the greater world can consume. You may expose coarser grained services to the outside world, but that would be a whole separate team, right? So it's just moving towards this very dynamic, fluid, not just architecture, but just organizational structure at a technology level.
All right. Well, that actually is the short version because we have a 40-page white paper on this topic. Considering our limited time, let's move on to just a couple more.
Sure.
Actually, this will probably be the last one, and this one came up a few times too. What are the challenges for developers when starting with a microservices-based architecture? So you need to
Mhm.
figure out how to spawn multiple services on your workstation, test, and then integrate. What are some of the challenges that we see for developers? Maybe, for
Yeah,
example, Java
you
developers.
know, I'm gonna come in as, you know, I'll tell this as a personal anecdote. It's challenge. What challenge did I have, right? Because I come from a Java background, enterprise Java background. Um, it really the challenge is moving away from app servers, moving away from some of the things you take for granted on in local development, not having like not really doing much concurrent programming, multi-threading and stuff like that. And then you give things up. Like say in Spring, if I want to make a transaction, I can just annotate, you know, an endpoint as transactional. But then I'm relying on like the secret, you know, sauce under the covers, like thread local and to kind of you know, add context to the transaction, and you lose that, right? So you are losing some conveniences. So it's not the challenge isn't just to rush into a tool. The challenge is to consider this, that you're learning a new style of architecture. Take your time and don't beat yourself up if it doesn't come right away. It's that you need to think about, like, you know, in a distributed system, how do I do things like maintain ordering of things? How do I handle transactions? How do I handle the fact that, you know, across network boundaries, especially I'm not integrating with one fat, you know, like relational database, is two different services might have different views of the world. They might have, like, you know, in an e-commerce context, they may think that a particular product has a different inventory level. So how do you handle eventual consistency? And it takes a little bit of it's not this like immediate, oh, I just need to learn a new syntax. It is reading things like domain-driven design. It's reading our white papers. And you know, frankly speaking, if you're doing this, is, you know, getting in touch with us and letting us help you out. You know, we have training available, and it's not being afraid to go back. Like, for instance, I'm always like, you know, I'm a beginner in this. You know, like right now in Toronto, I'm running a book club to embrace more pure functional programming. Just being willing to say that, hey, I've got some stuff to learn here, and it's not going to happen instantly, but working with your team, and it's a lot of fun. That's the one thing I want to say is, you know, doing this on the Walmart project was a blast, because not only were we solving real problems for Walmart, learning just a totally new way of architecting systems, it worked, and it was fun. So that's what I would say.
Okay, well, folks, I know that you have a lot more questions, and unfortunately, we're going to have to call it quits for today. Feel free to email us, though. You know how to get a hold of us. You can ping Kevin on Twitter. And thank you very much for your time today. I hope you enjoyed the presentation. We'll be sending you out the slides and the webinar recording within a couple days. So stay tuned for that, and have a wonderful day. Thanks again, Kevin.
Thanks, everyone.